Okay, so we're gonna go through a few definitions here. We're gonna first talk about when a function is called injective. So a function is injective if whenever we have f of a equaling f of b, then we must have that a and b are equal. So an example of an injective function would be something like this f right here from the set A, where these are the elements of A, and then these are the elements of B, and is just, denoted with these arrows. So for example, f of star equals b, or beta, right here, because star is sent to beta. And you can see that if we ever have, we can't ever get it that, this side is going to be equal, these things will be equal when a and b are different for f. To put that in contrast, we could see that g is not injective. And the reason why is because if we can have g of 1 equals alpha and g of 2 equals alpha. So we have g of 1 equaling g of 2, but yet it's obvious that 1 and 2 are not the same element. So here g is not injective. And then we should also see that h is also injective, and you can test that on your own. And that's when a function is called injective. Now we need to go over when a function is called surjective. So going back to our examples, we have that f now is no longer, f is not surjective, right? So why is f not surjective? Because we need to make sure that for all the elements inside B, for all B inside capital B, inside the set B, there exists some little a contained in the set A with f of a equal to b. But we can see that there's some element, there's 5. 5 is contained in B, but there's nothing in A that goes to B under F. So this F is not surjective. But again, we should see that G is surjective because we have it that for any of these, we can find some element that gets mapped to it. And H as well is also surjective. And H is our perfect example for our next definition. A function is called bijective if it's both injective and surjective. And we should see that H is both injective, it's injective, and it's surjective. So then therefore H is bijective, while F and G are not bijective because F is not surjective and G is not injective. H is the only one that's both, so H is the only one that is bijective.